So this is as much as anything kind of lessons learned from doing this in a whole bunch of projects over the last 20 years. And what I think a lot of it boils down to is, if you really want to become data-centric, and in addition to learning all the stuff you're just learning, we think you need what we call a core model and a data-centric architecture. And we're going to talk, obviously, about what each of those are and what they entail, and roughly how to get one of each. So what we call a core model, we sometimes call an enterprise ontology. It's just, can you build a fairly elegant, and by elegant we mean, less than 1,000 concepts. And when we say a concept, we mean a class or a property. So a piece of metadata or schema or something that you would have to learn in order to master the information of your enterprise. So is it possible? Well, it is possible. Spoiler alert. It is possible to get to that level of elegance and cover pretty much everything you're going to find in your enterprise. That's the one side of this. And then the other is, if you step back and look, most of your enterprise architectures were designed with an implicit idea that they were supporting applications, and a lot of functionality is deferred to the application. So we've solved all the problems that need to be solved over the last 40 years, but we've solved them in a way that sort of locks in application centricity. So the other bit you need as you start to grow this out is an architecture that can support this and that can evolve. And we're gonna talk about some strategies of governing and evolving this. So you guys have been looking at this. Well, what is so cool in many ways? For the longest time, people called this the Holy Grail, and then they'd come up with these tiny bespoke solutions for part of the Holy Grail. But when you jump back and look at what is actually possible with this triple store stuff, in the first place, we can render any information that's in a relational or structured database as triples, but we can also reach in anything that's semi-structured, XML, JSON, HTML. We have one of our guys just reached into a Git repository and turned it into triples. So all of that is not only harvestable, but harmonizable, if that's a word. There's now, for the longest time, it was pretty hard to get triples out of unstructured text. We did a project a long time ago where with a company that does a lot of legal publishing, so they get 1 million case reports a day. It's kind of amazing. And their previous process was to send these documents off to the Philippines, and people would read them and tag them, and then they have programs that would tokenize. But it wasn't really working all that well. And we worked with them on an ontology, but they had another team of linguists, computational linguists, who were able to comb through this stuff and actually turn it into triples and harmonize it with, obviously they had a lot of structured data. They knew every lawyer and every judge and everything in their structured data. The good news is, in the intervening 10 years, NLP and AI have gotten pretty good now at reading unstructured text. It was always pretty easy to find the named entities because they're just kind of sitting there, easy to be harvested, but it was always more subtle to find the relationships between them. But they're getting a lot better at that. So, we've done a couple of projects where we do exactly that. And then social media and the like, there's a lot of data that already exists as a graph. So obviously that's pretty easy. So, that's kind of the holy grail here is, harmonize all of your information, not just your structured information. So when we talked about having a simple core, we're shooting for something, and this was a D3 sunburst representation of some ontology. I don't remember which one it was now, but just give you an idea that you could just about print it on a plotter or stick it up, or just sit down. A human can learn a few hundred classes and a few hundred properties, especially because they already know half of them. I mean, half of the things that are in there are person and organization and project and event, and just things most people already know. So you have to learn a few hundred things. And if you do this properly, that is kind of the keys to the kingdom for all of the information in your enterprise. Here's how we think of how that can work and how you get the amount of resolution and fidelity, because in a large organization there are typically thousands and often tens of thousands of applications, each of which has thousands or sometimes tens of thousands of attributes and tables. So there's all these concepts, and at some level it's easy to believe that they're all necessary, and there really is many millions of fine-grained distinctions, but actually there isn't. A lot of it is just the way things happen, or the fact that you bought a package and it named everything 10 other different ways than every other way you've done it. But at some level, people think, wait a minute, I can't take all of that and put it into 500 concepts and not lose something. Well, the way you not lose something is by the skillful use of categories or taxonomies. And give you an idea of what we're talking about here, most companies, have lots and lots of data. They have millions or billions of individual rows or triples or facts or whatever you want to call it. There's a ton of instance data out there, but a lot of places probably have on the order of thousands, maybe tens of thousands of categories or taxonomies, ways that you can make a fine-grained distinction. Like an insurance company categorizes people based on their gender and based on their age group and based on their driving history and based on this and based on this. These are all kind of tags, and each of those tags don't have any further structure or triples or anything, but they need those tags attached to the individuals in order to underwrite insurance. You can't underwrite insurance merely by knowing that somebody is a person who owns a car. You need, some of these, finer grained distinctions that we refer to as categories and taxonomies. And then, sorry, the reveal didn't go in the right direction here. And then what we're talking about at the core, they're the key concepts. That's your enterprise ontology, the small number of concepts that really cover everything down below there. I like to think of that sunburst that we had earlier like a lens, that if you know those several hundred things, and if the rest of your data is mapped to that, and the mapping can go, I don't know, Phil probably didn't have a chance to get into this, but there's yet another W3C standard called R2RML, which is relational to RDF mapping. And there's two things that are kind of genius about this. The first one is that the map is also in triples. Therefore, the map is data, and it's first-class data that can just live with everything else, which is kind of cool. But the really cool thing is they've created a map in such a way that you can run it one direction and go from relational through the map, just like you would with ETL. You get triples out the other end, put them in your triple store. But if you wake up tomorrow morning and decide, I really don't access that data that frequently, I don't need to keep loading it every night and filling up my triple store, why don't I leave it where it is, but at query time, run through the same map in the opposite direction, just pick up a handful of, whatever rows you need to answer the query, turn them into triples at runtime, and they come into memory and then vanish when your query goes. So anyhow, that the idea here is that those kinds of maps can work either way, but one way or another, you've mapped your data landscape to this one lens, which is your enterprise ontology. And as long as you can query those concepts, everything else is a specialization. It's a subclass. It will come along, so you can and you can follow your nose from that. So you start the query with person, and you find out, well, in these systems they have workers and employees or patients or providers or what, these different kinds of people, but they just start showing up, and you see different information about different people. So it's kind of a way to mentally manage the amount of complexity that actually exists. It's, we think it's in most cases at least 100 times simpler than what you have to do now in order to master all that complexity in situ, where it is. Makes integration simpler. In fact, in the end game, there is no integration. There's a group in Canada that are producing something that I love. It's the Data Coalition Alliance or something like that. I forgot what it's called, but they're promoting the idea of zero copy integration, with the idea being that, right now we think of all these pipelines, and data has to keep moving and being transformed from source to destination and on and on. And there's data leakage all over the place. And they're saying, and I totally agree with this, once it's expressed as a triple, it shouldn't need to move and be copied and transformed at all. Zero copy. It makes your data governance simpler, because you really want to govern at this level and then project down. Makes analysis, the guy that was doing machine learning, I think you're onto something with explainability of the black box. But on the other side, a lot of people are finding, the 60% of time that data scientists and machine learning people spend just data wrangling and quality and all that kind of stuff. If somebody's done this for you, you've got it, it's all there, it's all organized. If you have a data lake, this could be a lens on that. Those things are hideously complex, as a way of at least understanding where your GDPR risks are. They're almost all attached to people, so that's a pretty good place to start, and makes application development simpler, because this is all you need to be doing. Everything gets simpler. So the other side, and I'm going to come back a little bit to this idea of a core model, and I'll take questions, but the other side is we need an architecture. And when we actually, I've got one, I don't have my camera on. I just got one from one of our clients. It's got boxes and arrows and stuff, boxes within boxes, and it's like, man, if we're going to be truly data centric, we better put data at the center, and then figure out what does an architecture look like when data really is at the center. Well, it looks kind of like an onion. Imagine that thing in the center is data, and the rest of this onion is architecture that protects and enables the onion. And we started a conference about 4 years ago called the Data-centric Architecture Forum, just getting people together. Actually, Sandy was there on our first one, just getting practitioners together to talk about and work out what actually has to be in an architecture to support this. And we've been holding it, every year for the last 4 years now. And gradually, very vendors and practitioners and people are building out pieces of this. I would still say, I don't think there is a complete solution anywhere yet, but I don't think it's going to be too much longer. The idea is to have these layers that should be relatively simple. So I'm going to kind of go through. We from that onion, we now made a diagram that's a little more specific, I guess. So the very center, and we now call it the grapefruit inside the onion. It was kind of an accidental thing, but when we started, we made this little thing that looks a little bit like a grapefruit with odd shaped wedges. But each of these wedges represent a repository or some data that either is in triples or we know how to turn it into triples on the fly. So the darker yellow stuff is data that is curated. One of the big issues a lot of people get into is, there's the whole open world problem with semantics, that if you have to keep thinking, well, anything could happen, there could be anything attached to these, and all our information is incomplete, that drives corporate people nuts. They like to have an inventory system. If you've got 1 million parts, there's 1 million records there, and there could be more. No, they don't think there could be more. They think it's buttoned down. They think their employee list is complete, which it is. Don't argue that. But you want to be able to partition this and say there are parts of your information ecosystem that are highly curated and closed, and you know exactly what's there, and every employee has exactly one social security number if you're in the US. Whereas the other side, the left-hand side, is data that is, maybe it's been harvested, maybe it came from the web, maybe it's of questionable quality. But in some use cases, combining that with curated data, maybe you find out things about your employees from social media. It's a little creepy, but it's just the first example that came to mind. But anyhow, so that's the idea. There are various sets that may have different levels of curation to them. There's a bunch of data that has been harvested and aligned, and a bunch of data that is mapped, maybe to linked open data cloud or some other relational database or anything. So that's sort of the core of the core. Coming out from that is a layer that knows how to federate over them, how to make a query and combine the results from multiple of those. And that's pretty standard now. A lot of pretty much all the Sparkle engines support that now. One query to access multiple stores. The next layer out, we're advocating this where you know about a core model. And in fact, some parts of this core model are architectural. So if you have a model-driven environment, for instance, this part of the core would know the difference between a view and a form and a report or whatever, and fields, and how to take an attribute and put it onto a field. But it's also the central enterprise ontology that things are going to conform to. And by the way, you're going to do most of your security, your authorization to. So that's where shared meaning lives. And then you specialize further out. So data security lives at this level. There's both authorization. Oh no, I guess authorization is further out, sorry. So this is mostly determining whether you can access a particular repository or not, and obviously logging for everything. Oh no, I guess this is where the authorization is. At one point we thought there's about 4 solutions to security now. We're seeing all of them play out. And I think within the next year or two, we'll figure out which ones are working the best. One is at this layer, rewrite a query so that a user could only see what they ought to see. Some people are experimenting with pipelines, that there's one query of what you can see, and then it pipes into what the next query is of what are you looking at in this view. Well, we just talked to a vendor that is implementing what we call triple pattern security. In other words, class, property, class combinations down in the database engine itself. And other people are doing this using named graphs. And there's a lot of ways to do this. So when I wrote this slide, I was thinking of rewriting, but there are more than one ways to do that. You also want to have some place that can detect and report suspicious patterns. This is where you want to prevent breaches. If all access has to come through one place, you got a pretty good way. You can never eliminate a breach, but the fewer access points, the better. I mean, most breaches are because there's so many ways in. From this point on, the circles get a little epicentric, meaning they're shifted to the right, because some of the concerns deal more with the right-hand side of the grapefruit, the curated data. So things that you harvest from the web, you care less about identity management, things like that. I mean, not that you don't care about it at all, but you got a lot more concern about it on that right-hand side. You know, this is where you want to say, if I'm creating a new URI, a new instance, how do I detect whether I've already have this one and I shouldn't actually create it? It's the same as one I already have. You know, you should be doing that in this layer. But if it is truly new, this is where you mint URIs and any other kind of identifier, aliases, etc. You know, because a lot of times every legacy system you have has an identifier. They know they can't get to a universal ID. Everybody's tried that over and over and over again. It just doesn't work. This gives you a way to say, I happen to know that this system uses employee ID and this one uses email and this one uses social security number and this one uses this. We're just going to keep those in a bag here attached to the one individual. And then if you do need to do integration, you just send them, here's all your aliases. You know, how do you identify this person? Integrity management also right shifted here because it's more about the curator. It's not that it doesn't apply, but we end up doing a lot more effort with it on the curated data. You don't need to do referential integrity, but you do need to do constraints and validation, things like that. Somebody asked earlier about atomic transactions. You know, this is where that lives. And also the triple store vendors don't have built-in trigger mechanisms, so you kind of have to invent that in the architecture. We've been doing some of that. And provenance. In other words, on ingest, where did this new information come from? Such that if somebody later wanted to know, you literally can just click on a triple and say, oh, that was data entered by this person, or we harvested this from this system, or we inferred this from these other things, or this is merely an aggregation of these 10 values, things like that. Then we've got behavior. This is where there is some code. It's probably like a microservice. There's many different ways you might implement it. Typically, people want to have geospatial information. You know, how far is point A from point B? How much do these two things overlap? Temporal, you know, when was this true? How do you manage workflow and keeping track of queues and expediting things to supervisors? You know, scheduling, like project management scheduling, and prediction. You know, if you want to have a prediction engine to predict and then validate things happening. And of course, you know, you might as well have the whole range of Excel-like functions that people can use as they build out application behavior. And then, you know, there will be local extensions. We're starting to think that it may be possible. We haven't done this yet, but for individuals to extend the ontology. In other words, you know, in my opinion, most rogue IT systems were created because somebody needed just to add a couple more categories to certain data and do a little bit of analytics on the side. Well, it would take you a year to put a new category into a legacy system. So instead, they typically do an extract, put it in Excel or Access or some local database, add their 1 or 2 columns and do their analytics. We'd love for them to be able to just add a category onto, let's say they're salespeople and they want to add a few more categories onto their prospects. Just add them on, and you don't necessarily have to get everybody else in the company to agree. Just anytime you do a query of your prospects, these categories are added on, you can do your analytics there. And yeah, I think most of the extensions are going to be little tiny taxonomies, VIP, VVIP, or high net worth individual, or ultra high net, or very high and ultra high net worth individual, those kinds of things. And then authentication. Most people rely on, there's plenty of authentication solutions out there. So most people rely on that as kind of the outer thing. Should you be in this architecture at all? What endpoints can you get to? What repositories should you stay away from, et cetera? And then at the very outside of this, we think there's probably 3 generic categories of user interfaces. I think it was Ed mentioned they'd done some model-driven user interface. So, it's certainly, I think, a great thing to do in this kind of environment. And what model-driven means is you can create a model of what a view or a form should look like. The model itself is just more triples. And you just have to have a little bit of engine that inspects that model and says, oh, form number 27 has these 4 fields on it, and gets those 4 fields, presents them, somebody edits them or does whatever they do, and they say save, and that becomes, 6 new triples to get persisted in the triple store. I think it's a great solution for 90% of your UI, because in most systems, most stuff is relatively simple forms and cards and views and dashboards and all that kind of stuff. If you're going to go that route, you will need another set of UI that is for the people who are building the models. You want to make that easy and not error prone. But then, of course, you should also allow, most systems have a handful of user interfaces that you really should put some effort and hand write them in code and make them beautiful and interactive and graphic and all that kind of stuff. So there it is. If anybody wants, we can get, we call this the placemat because it's the size of it's 11 by 17. We used to laminate them and give them out at the conference, but we can give you a digital copy of this if you're interested. It's just kind of it's not even a reference architecture. It's a reference sketch, I guess, of what we think you need to have in an architecture to really build this out completely. And what we suggest and what we observe in some of our clients is the way to grow it out. That purple box on the left called the enterprise core is, you get started, and we'll have a couple of slides in a minute on this, but you get a little bit of population of part of your core model. And then as you start doing projects, on the bottom, the blue, you're just kind of expanding the footprint of, how much of the firm is now conformed to the enterprise ontology and is in triples and in the knowledge graph. You might start with operational risk and move to fraud and trade surveillance and blah, blah, or depends on what industry you're in, obviously. But the other thing we advocate is, in parallel, start trying to grow out your architecture, your infrastructure. And usually, and the reason we've got the red boxes growing and the blue boxes, just waterfalling, is because the domains, just each one is another domain, and it kind of extends the core. I mean, they're related. I suppose it's making the core bigger, but each domain is kind of independent. Whereas every time you grow the infrastructure or the architecture, it's now available for everyone. But a lot of our clients, it's not quite as pretty as this. They'll do the one project on the left, and maybe they'll do several domains before they do very much work on the architecture at all. The easiest way to go is to treat your knowledge graph sort of like a data warehouse. The data is coming in, we're only reading it. It's not very dangerous, but it's useful. And so people can do many subdomains, and then they sort of look at it and go, hey, wait a minute. If I've got all the data from this subdomain in the knowledge graph, and if I added just a little bit of architecture to allow me to directly update it in the graph, I can actually start decommissioning functionality, and maybe not even whole systems, or maybe parts of systems. I can quit doing this one use case back there in the legacy system and pumping it through. I just do it right here in place. And as they start coming to that conclusion, that's when the architecture and the infrastructure start growing out. Here's a slightly different Chevron style way of thinking about this. Is kind of a natural progression. Initially, we, in the green, create the core model and get some data that conforms to it. This proves probably one of the biggest problems in this is it's hard to convince enough stakeholders that this is possible and useful. So that green thing is mostly to say, look, here's how you bring data in. You really can conform it to a simple model without losing fidelity. And they start seeing some of their own real data combined in ways they've never seen before. So that starts getting them excited enough to, do some more domains and continue on. And then in the blue, you've got a knowledge graph. You can do some network analytics. You can do some things that are either hard to do or impossible to do where the data was. That starts getting people excited. They start seeing some new value. Then, as I said on the previous slide, now it's time. You can build a simple app, maybe just a little form-based thing that only does a few little things. You need enough architecture to do some identity management and constraint management, a few things like that. If you start looking forward, you're going to realize there are going to be hundreds or thousands, probably thousands of use cases eventually. And if you just do the math, it's worth it to invest some time in saying, how can I do this in sort of a no code, low code kind of way, then start building out some simple ones of those. And then finally, you're kind of ready to start building more sophisticated applications. Here's kind of how we pitch this. We call it think big, start small. For a long time, we thought creating the enterprise ontology was the hard problem, and that if you could help people with that and solve it, that was it. They had what they needed. But we discovered, doing several of them, that they were just shelfware. People didn't know where to go with them next. They were actually moderately large projects, so they're hard to get started with them. And we were observing what other people were doing. Almost everyone was doing proofs of concepts or very small, isolated projects that could get something done, but it was either so small it seemed to be irrelevant, or it wasn't. You couldn't. It was just another silo. It was a semantic silo, but a silo nonetheless. So we finally figured you have to kind of do these two in tandem. You have to do enough thinking big so that whatever you implement is sort of future-proofed, but you have to actually do something with real data and solving a problem that isn't already solved. Now, it's actually, at first, that sounds kind of grandiose, and the first few times, it did take a fair bit of time to build that first enterprise ontology. But what we've been doing over the last decade or so is evolving our starting point. Phil may have mentioned GIST. It's our minimalist upper ontology. It's free and it's freely available on our website. So we always go in and say, if we did nothing else, GIST is probably half of your enterprise ontology. The things we discover along the way are probably going to, there's one or two exceptions, but probably going to be an extension of concepts that are already in GIST. And you can kind of focus on the area of the domain where you're starting without too much risk of needing to refactor. So that's something we do. Just to give you an idea what the deliverables are. In the think big, what we're trying to do is maximum coverage with minimum concepts. And the thing that comes out of that is the enterprise ontology, as we just said before. And the start small side, you want to be able to show that you can provide value that is either difficult or impossible to provide from the current systems. And sometimes, God, it's so simple. We have, we do this thing called competency questions, and so we help the business users at the front end of the project define some things that are currently hard, but maybe not impossible to get the answer to. And we want to get to where they're easy and self-service. And sometimes when you describe an example from another industry, you just shake your head and go, really? That? And I'm thinking right now, we did one with an insurance company where one of the questions was, tell me all the agents a customer deals with. And you think, God, you're an insurance company. Surely you know that. And it turns out, well, I mean, they had these gigantic data warehouses and stuff. There was one person in the company who could find out that information, but it would typically take a day or so. And they were, quite backed up with all kinds of other things. I mean, nobody could just go into a screen and type it in. How many agents does this person deal with? And partly because of mergers and acquisitions stuff. But anyhow, it gives you an idea of sometimes it's a pretty simple question that's currently hard to answer. And if you just bring some data together, put in a triple store and write the Sparkle query, you go, yep, there it is. A few more interim deliverables. I'm not going to spend too much time on this one, but it's just, like any kind of project, you want some things to review with users and check along the way. Same with this one. There's the competency questions. You have to actually extend the core to, cover a few new concepts that you discover in that domain. There's the TARCL that Phil had mentioned. And this doesn't take a huge amount of time. This is maybe a little short. Yeah, it's probably about, we might want to revisit this slide, but it's not too far off. And you can do them kind of overlapped. It's better to start the think big part first because, you're specializing some of those concepts. So there it is. We think this is much better than staying stuck where you are. Somebody said the big challenge is changing the way you think. It's, as you can see, it's simple. I just showed it in a few slides. It's just not that easy. You have to change the way you, actually a big thing is changing the way you manage and budget and manage projects. People in large organizations have learned over decades how to get a project approved, and it has to have an ROI, it has to have this, it has to have that, and all these kind of expectations that they're not violated by this, but they're just different enough. People aren't quite used to it. And you need some data modeling skills, and they're slightly different than they were in the traditional world. And you want to be able to shift as much as you can to being model driven. And as I suggested, you're gonna need an architecture, and it's going to be partially build your own and partially reuse some parts, and wait for vendors to fill in the missing pieces there.